Hi everyone. Today we'll be discussing the LeetCode problem of the day, two best non-overlapping events. So here you are given a zero index 2D array of events which will represent start time, end time, and values. So suppose you have few events like this, end time. So this has a value 5, this has maybe 8, has 4, has 7. So if you attend an event, you will receive the value points. So you can choose at most 2 events which are non-overlapping and such that their sum is maximized, and you just have to return the sum. Also note that the start time and end time is inclusive. That means if an event is running from 5 to 7 and another event is starting from 7 to 9, so if you attend the first event, you can't attend the second event because the end time and the start time overlaps. So you can only attend this event if the start time is at least 8 or greater. And also note that you have to attend at most 2 events. So that means you can attend even one event or 2 events. So in this example, I think the maximum answer will be when you attend this event and this event, you'll get the maximum value as 9. Now let's quickly look at the examples. In the first example, you have 3 events, 1 to 3, 3 to 5, and then 1 to 4. So we can see that this event overlaps with both of them. So if you attend this event, you can attend the above 2. And if you attend this event, you'll get the maximum value 3. But instead of attending this event, if you attend these both, you'll get the value as 4. So 4 is the answer. Now in the second input, again, with this event, these both events are overlapping. So if you choose to attend these 2 events, you'll get value of only 4. But if you choose to attend only one event, then you'll get the value as 5. So 5 is the maximum. So that's the answer. And finally, in the last example, you have 3 events. These both are overlapping, so you can attend only one of them. So you can choose to attend this 3. And after that, if you choose to attend this 3, you can attend this 5 because start time and end time are overlapping. Okay, in the diagram, it might look like these both are overlapping, but if you see the events, so this event is running from 1 to 5. And then this event is running from 6 to 6. So here the start time of this event and end time of this event is not equal. So you can attend both of these events and the maximum value you can get is 8. Now coming to the constraints, the number of events can be up to 10 power 5 and the events of I dot length will be 3. That is start time, end time and value. And the start time and end time can be any value from 1 to 10 power 9 and the values can be from 1 to 10 power 6. Now let's go with the approach. So suppose you have this input where you have 5 events. So the first logical thing we can do is sort the events based on the start time so that all the events are coming in the order. For that, we need at most two events to maximize the value. So first, let's fix this event. So our sum will be 4. After this, we need to check in this part and find another event which is maximized and which is not overlapping with this 1 to 5. So for that, one thing we can do is we can iterate on all these events and see that the 6 is the maximum value which is not overlapping with 1 and 5. So we pick the 6, add it to 4. So total value we get as 10. So that means when you pick this value, you get the maximum value as 10. Now the same thing you'll repeat. You will pick this element next. So while picking this, you'll get the value as 3. Now to pick another value, you will again iterate on all this part and find the maximum value, which is not overlapping with this 3 and 5, and that you'll add to the answer. But on doing this, your complexity will be order of n square because for each event, you're again iterating on the entire right part of the array to find the maximum value, which is also not overlapping. So here, like I discussed, we have two parts to get the second event. So the first part is the max value. So in the right part, we need to pick the max value. And in the max value also, we need to pick the non-overlapping max value. So we need to solve two problems to reduce the complexity from order of n squared to order of n. So let's look at the first problem, which is the max value. So for that, let's look at the suffix sum. So suppose you have an array like this, 4, 7, 8, not 8, okay, maybe 8, then 5, 4, 6. So suppose you have this array. Let's initialize a suffix array. So suffix of array, suffix of I will denote max value from index I to index n minus 1. So this is how we will initialize our suffix array. So according to this definition, suffix of the last element is equal to the max value from that particular index to the last element. So suffix of this value will be 6. Let me write the indexes as well. Yeah. Next, suffix of this value will be the max value starting from index 4 until the last of the array. So the max value among these two will be again 6. So now suffix of 3 will be again max of these three elements, which is again 6. Next, we have suffix of 2. Suffix of 2 will be max of all these elements, which is 8. And here we'll again have 8. And maybe if we have a 9 here, then here we'll have 9. So this is how we have built our suffix array. The way we build it is, we can do like suffix of I equal to math.max suffix of I plus 1 value of I. So the suffix array is same as the prefix array, but this is just in reverse. So now using this suffix array, I can answer one query very quickly without iterating the entire array. So my query is, what is the max value which is starting from index 2 until the end of the array? So for that, I no need to iterate on the array from index 2 to index the end of the array. I can simply look at the suffix array and that will be our answer. So let's verify the same thing for this index as well. So I have a query, what is the max value from index 1 to index 5? So I can simply look at here and say 8 is the max value. So you can see in this part, 8 is the max value. So now using the suffix array, the first problem, which is to find the maximum value, is solved. So like we saw, we have another problem, that is, out of these max values, all the events, some events can overlap with the first event. So now let's see how we can solve the problem of the overlapping. Me again copy the example. Yeah. So first, let me build a suffix array like we discussed. So suffix of last will be 6. Then for this element, it will be max of 2 or 6. So it will be 6 only. And for this, let me just change the example a bit because the suffix array is getting filled with all 6. So I can make a 6 here, maybe 5, 2. Yeah. So now the suffix array will be something like this. So in the last element, we'll have 2. Then here it will be max of this event and this 2 value, so which is 5. Then here it will be max of 6 and 5, which is 6 again. And here it will be max of 3 and 6, which is 6. And here max of 4 and 6, which is 6. So this is our suffix array. So from here, what we can see is if we pick this event, which will give you a value of 4. Now for the other event, you can simply look at the suffix of this value. I mean suffix of the next index, because suffix of the next index will give you max value from starting from this index until the last of the array. So from this example, the value will be 6. But if we see that the 6 is coming from this particular event, which is starting from 5 and 6. Since our first event is running from 5 and 6, and the second event is starting from 5 and 6, so we can't choose this 6 because the start time and end time are overlapping. So that means even though we found the max value, we can't pick this event because the start time is overlapping with the end time. So one thing we can see that for this event, the start time is exactly equal to the end time. So if we move to the left, we will always find the start time less than the current start time, since we already sorted the array with this start time. So this event fails. So the only logical way is to look at the next events, because if, in hope that if we move to the next events, we will find some event with a start time greater than this current value 5. So this 5 is failing. So next maybe we'll look at this 7. And maybe we look at this event, and for this event the start time is 7. So 7 is greater than 5. So we can definitely pick this event. And from the suffix sum, we will see that the value is 5. So instead of 6, our answer will be 5. So to exactly put in words how we solve the second problem where we don't want the overlaps. Also in the suffix array, one thing it's sure that the suffix value will always be sorted in descending order, because in the last value will always be smallest, and as you keep moving to the left, the value keeps increasing. So that is one property. Now for the first event, you are looking to find an event in this range from i+1 to the last element. For that, suppose you want to do a binary search and your mid is here. So first you'll check whether you forget about the max value. So first you'll check whether you will be able to pick this event or not. So for this event, the start value is 5, the end value is 5, they are overlapping. So you'll say that you can't pick this event. So once you are not able to pick this event, even if you move to the left, your start time will always decrease. So you won't pick any of the events which is left of this value. So the only way is you want to check to the right of this in hope that the start time will increase and you will be able to pick the event. So in the binary search, suppose this value fails, then my next search space will be from here to here. Now in this, I'll do the binary search, and suppose I landed here. So at here, I'll see that my start value is 9, which is greater than 5. So definitely I can pick this event. So from the suffix array, I'll find my maximum time, which is 2. So I say that 4 plus 2, I get my answer as 6. So once I find my answer at one particular event, if I move to the right, my max value will always decrease because of the suffix array property. So the only best way to maximize our answer is to move to the left in our search space. So now my search space will reduce something like this. Now this will be my mid value, and here the start time is 7. 7 is greater than 5, so I'll be able to pick this value, and the new max value is 5. So now instead of 4 plus 2, I can pick 4 plus 5, and which will give me the answer as 9. So the same thing you'll repeat for each of the starting event. So first for this event, this will be my entire search space. Then if I start from here, then this will be my search space, and I'll repeat the process for the same. And like we discussed, the suffix array is used to solve the maximum problem, and the binary search is used to solve the overlapping problem. Now let's code the approach. So the first thing we'll do is sort the events. So arrays dot sort events, and we'll sort the events based on the start time. So a comma b, then integer dot compare a of 0, which is the start time of the first event, and then b of 0. So once the events are sorted, let's create the suffix array. So while we build the prefix array, so first we'll set the index 0, and then we'll start iterating from the index 1. So similarly for the suffix array, we need to first set the last value, which will be events of n-1, 2, and then we will start iterating from the second last element. Greater than equal to 0, I minus. We'll iterate in the reverse order. So suffix max of I will be max of I plus 1 or the current element, which is events of I 2. So this is how we build our suffix array. So once that is done, we can start iterating on each event, and then for the other event we can do the binary search. So let me first take answer equal to 0 and then start iterating on the events. Note that I'm iterating till the end of the event, because I'm iterating even at this event, because if there's an answer that we only pick one element, so that case we might miss if we iterate only till the second last element. Even though if when we iterate on this event, we don't have anything to the right, in that case we'll only get the answer from the attending the one event. So we need to check that case also. Okay, so we start iterating on the events. So first sum, we'll get it from the current event, events of I 2. Now to get the second event, we'll do the binary search from index I plus 1 to the last of the array. So sum plus equal to max event. It will start from I plus 1, go till n-1, and the end time is events of I1. And we need to also pass the arrays events. And once you get the sum, just maximize the sum. So answer will be math dot x comma sum, and at the end return answer. So let's quickly fill up the binary search function and we'll be done. So first is the start, left, then right, then end time. Then we have the suffix max, and finally we have the events array. Here let's just initialize the variable max initially 0 and start the binary search. So while left is less than equal to right, equal to left plus right minus left by 2. So now we are on the mid. So first thing we'll do is we'll check if the current mid is overlapping with the end time or not. That means if events of mid and 0, which is the start time, which is strictly greater than the end, that means it's not overlapping. So since it's not overlapping, we can assign max equal to suffix max of mid. So from the suffix max, we'll get the max value starting from mid until the end of the array. So suppose our mid is here And let's assume this is not overlapping. Now the current answer is 6. So to find any greater answer, we have to move to the left because the suffix array will increase from right to left. So after finding the answer, we can do r equal to mid minus 1. So that we'll search in the left side space in hopes that we'll find a better answer. Else indicates the current event is overlapping. So since the events are sorted in increasing order, if the current event is overlapping, then we should move forward in hopes that we will find a greater starter time that will not overlap. So left equal to mid plus 1. And at the end, just return the max value. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, first thing we are doing is sorting the array, which is order of NlogN. Next, we are creating the suffix array, and that will be order of n. And here we are iterating on the array, and inside that, for each iteration, we are performing the binary search, which has a complexity log n. So overall, this for loop will have complexity n log n. So total time complexity will be order of n log n. Coming to the space complexity, we are only creating a suffix max array, which is of size n. So space complexity will be order of n. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.